All right, today we're going to continue our discussion of U-substitution. Today the only difference is that they're not telling us what to use for our U value. We've got to choose that, and so they're giving us some ideas of good choices of U-substitution. And really all of them boil down to this last one, that it appears as the inside of a function of composition. Now, these are ways that it can be the inside of a function. Maybe it is raised to a power. We saw a lot of those yesterday in our notes. Or maybe it's in the denominator. Now, it doesn't have to be raised to a power in the denominator, because if you think about it, anything that's in a denominator, like this, for example, that could be written as x plus 1 to the negative 1 power, which now makes it raised to a power. So all of those inside functions really would work for us, even the denominator as an inside function. So we're going to take a look at some of these and choose our U value, work them out just like we did yesterday. So in example 1, it looks like our inside function is going to be the x squared plus 1. So we're going to let U equal x squared plus 1. So the derivative of U is going to be 2x, move the dx, and it looks like that matches up really well for us on this one. So we're just going to replace the 2x dx with du. We're going to have the integral of U squared du. So we integrate that, and we get U to the third over 3 plus c, or 1/3, x squared, 2x, x squared plus 1 to the third power plus c. All right, in example 2, it looks like the inside function is the angle inside cosine. So we're going to let u equal 5x, so du is going to be 5 dx. Looks like this one matches up well as for us too, so we're just going to have the integral of cosine of u du, and the integral of cosine is sine, so we get equals sine of u plus c, or sine of 5x plus c. Alright, so far so good. So now we have one that may require us to do a little more work, but remember that this is the same as the integral of 2x minus 1 to the 1/2 power. So we're going to let du equal the inside function, 2x minus 1. Sorry, let u equal. So the derivative of u is going to be 2, move over the dx. So du is 2 dx. But we don't have a 2 dx. But remember, we can do some manipulation here, so I'm just going to divide through by 2. So dx is du over 2. So we have the integral of u to the 1/2 du over 2. And we can bring this 1/2 out to the front, times the integral of u to the 1/2 du, and then we just integrate as we would normally, and we have u to the 3/2 over 3/2, or times 2/3, and that is times 1/2 plus c. So that's going to be 2/6, or 1/3 of 2x minus 1 was our u value, to the 3/2 power plus c. All right, on number 4, remember this is sine of 3x to the second power times cosine of 3x. So my inside function is sine 3x, so I'm going to let u equal sine 3x. So du is going to be, derivative of sine is cosine 3x times 3, and then I'm going to move my dx over to this side. So 3 cosine 3x dx. So if I look back over here, I don't have a good match for that. I've got the cosine 3x and the dx, the cosine 3x and the dx, but not the 3. So I'm going to divide both sides by the 3, and then I can replace this cosine 3x dx with du over 3. So I'm going to have the integral of u squared, and then all of this is replaced with du over 3, or 1/3 times the integral of u squared du. All right, so we get 1/3 u to the third over 3 plus c, or 1/9. U to the third is sine of 3x to the third plus c. Or I guess you could write that as 1/9 sine cubed 3x. Either is fine. All right, so example 5 is a good example of one of those where we're talking about looking in the denominator, but if you see, the denominator is already an inside function as well, so we probably would have chosen it anyway, but we're going to let u equal the inside function x to the 6 plus 1. So du equals 6x to the 5th, and then move your dx over, so dx. We have x to the 5th dx, this part, but we don't have the 6, so I'm going to divide by the 6 and replace this with du over 6. So we're going to have the integral of 1 over u to the third, and then du over 6. Okay, so I'm going to bring the 1/6 to the front. I'm going to rewrite this as u to the negative 3 power, and then we can integrate that. So when I add 1, I'm going to have u to the negative 2 power over negative 2 plus c, or negative 1/12 u to the negative 2. So what was u? X to the 6 plus 1 to the negative 2 power plus c. Or we could write that as negative 1 over 12 times x to the 6 plus 1 squared plus c. All right, we have one more example. So this one, we can probably tell that our inside function is going to be the 2x minus 1. I'm going to rewrite this real quick as the integral of x times 2x minus 1 to the negative 1/2 power. But still, my inside function is that 2x minus 1. So when I take the derivative, I get 2, and then move over the dx. So du equals 2 dx. So I don't have a 2 in here, so I'm going to go ahead and divide by the 2, and I can replace my dx with du over 2. But this is one of those where I have an extra variable. Remember, you can't pull out an extra variable. You have to solve for that variable. And so we're going to use our equation here and solve for x. So we're going to have u plus 1 equals 2x. Divide by 2. X is going to be u plus 1 over 2. So we're going to replace everything now. We have this x is u plus 1 over 2. And then we have our u value to the negative 1/2 power. And then the dx is du over 2. So we're pulling out a 2 and a 2, or 1/4 times the integral of u plus 1 times u to the negative 1/2 du. Alright, so now I'm going to distribute, and I have 1/4 times the integral of u times u to the negative 1/2. When you multiply, you add the exponents. So we're going to get u to the positive 1/2 plus u to the negative 1/2 du. Alright, so we're going to integrate that. We get u to the 3/2 over 3/2, or times 2/3, plus u to the positive 1/2 over positive 1/2, which is just times 2, or times 2 over 1, plus c. And so that's going to give me 2/12, or 1/6, and my u value was 2x minus 1 to the 3/2 plus 2/4 or 1/2, 2x minus 1 to the 1/2 plus c.